Okay, good morning, or should I say bon dia, because today we are looking at yesterday's Brazilian round 7 Excel esports case. It's my first time trying a live case in the Brazilian. I've done some of their back catalog recently, so I should say obrigado to the Brazilian host for a great case. Just a bit of an introduction. If you're watching this, I'm assuming you've tried the case or about to. Key bit of information is we're dealing with mouths and dentistry. We're given a map of a mouth where every number tells us where the tooth is. So the first number refers to the quadrant, so 1, 2, 3, 4. The second number refers to the kind of tooth type, and we can combine those two together to get a full tooth name. So upper right central incisor would be 1, 1. And that is all you kind of need for levels 1 to 3, and then it helps also helps through the whole case, but particularly levels 1 to 3, that's the information you're working through. I will say the usual caveats about how I do this. I've done some of the prep work, gone through the case a few times. I will say a bit about my live performance and what I did differently there to what I'm doing now, and vice versa. So yeah, I will try and make this as speedy as possible. I think it might struggle to get this under half an hour. That's always the aim. So let's get started. We're already over a minute. So level 1. So we need to know the quadrant number, which we know from the setup is basically the first digit. So we'll just take the left of that and we get the quadrant number. Then here it's slightly different. We're given the full number, but we need to know the second number, which is the right, and then we need to look it up in one of our tables. So let's quickly get our tables and we'll select this. Oh, don't want all of that. We're going to create names from selection. Actually, I'm going to cancel that because it won't like first digit as a name. So we'll just call that digit 1. And we'll call this digit 2 and then do the same thing as before. So Control Shift F3. It keeps thinking the right column is where the names are because it's got names rather than numbers, which I think is what's going on there. And then we can go back to level 2. So we're going to take the right of this. We're going to times it by 1 so it treats it as a number, and then we're going to wrap that in an X lookup. And we're going to look that up in it will be the digit 2 and return the type. And we get the type. And then level 3, we're reverse engineering this. So we're going to build a little let statement here. So we'll say let the digit be the text before this based on the space. We want the second instance. And then the... D was probably a bad name. We'll just use E for the other one to text after G9 based on the space, and then the second instance. And if I just put those together, we get D and E, which is, yep. But now what I want to do is I want to look those up. So X lookup D in the quadrant and return digit 1. And then we're going to join that with the X lookup of E in the type and returning digit 2. And we get 37, which if we fill that down, should give us all our numbers, and we'll just point to those and we see we're all correct. Okay, level 4. Now we've got this map, so we need to work out how to get this in a clockwise order in a single second. So I'm going to take each quadrant, work out where it starts. So it starts on 18, 21, 38 and 41 moving clockwise, but the 18 sector goes in reverse, so we'll say -1, 21 goes up, 38 goes down, and 41 goes up. So those are our kind of orders, and we can now create a sequence where we always go in 8 because there's 8 in each quadrant. We're starting at this number, taking those steps, and if I fill that to the right, we get each of the quadrants, and then if I 2-col that, those 4 selections, but scan by column, I will then get those in a complete order. So let's build a little let statement down here. So let's the teeth be that and the positions be that, and then what we want to do is we want to find the original. We know where we need to get the teeth expanded, so teeth split. So we will text split the teeth based on space dash space, and we want to multiply that with 1 so we get the actual teeth. So that gives us something's gone wrong there. I haven't actually then referenced teeth split. That's good. So then what I'm going to do, put this on a new line. We then want to know the original positions of those teeth. So we want to X match the teeth split in this cell here, and we'll we'll hard lock that. Oops, we'll hard lock that so we get the original positions. And then we want to change those original positions. So the new positions will be the mod of the original positions plus the positions move minus 1. Divisor is 3 because there's 32 teeth, and then we add 1 back on, which gives us our new positions. And then we want to find the new teeth position. So we get index back into this reference again, lock it based on the, doesn't like that because I'm not inside the formula bar. Based on the new positions, which if I've done that right should give us 11, 38 and 35, which it does. And so then we'll just text join those based on space dash space, ignoring empties. And what we're actually joining is the new teeth. Okay, brilliant. Let's fill that down. Let's copy those. Let's just reference them. And we get all good answers there, right? Level 5, we're at 6 minutes, so that's good. Okay, so now we need to, this is where it gets tough. So we're mapping into the patient sheet based on a patient number and then finding cells. So the way I did this, I firstly wanted to join patient, take patient and that to give me my patient number. And then what I want to do is I want to find this in the map. So I'm going to go to the brushing, I'm going to select this whole range. I'm going to go 1 extra column to the side and 1 extra row down just in case because of the shape of those are the gaps between each section. I'm then going to name this brushing, not burshing. Okay, and while I'm here I might do the same thing to the X-ray data because we're going to need to do something similar to this later. So we'll call that, again, do the exact same shape because that's going to help later. So let's call that X-ray 1. I'm going to call it X-ray 1 because later we're actually going to have to copy this for the version where we find the crooked teeth. So back to level 5. So what I want to do is want to find in map this, find in the brushing this item, which is in cell B5, which is what we expect. And we now need to have an offset. So we need to say, well, if this is where the starter cell is, we want the 16 rows below it and the 8 columns within it. So what I'm going to do is I'm going to do a cell offset cell address based on this. My row offset is a sequence of 16. That's nice and easy. The column slightly more confusing, a sequence of 8, but we start at 0 because we actually start in the same column as the original cell. So I've now got cells B6 down to I21, and now I can use my address lookup. So lookup in the brushing, and that gives me that. And what I'm going to do now is just sum those. I know I need the average, but if I average this, it will include all those zeros, which I don't want. But because the number of teeth is fixed, I can just divide the sum by 32. I then want the integer value. This was a mistake I made in the live case. I just rounded this, which meant half of them rounded up, and then I got it wrong. Now my range, I'm going to want to find the range which is given to us here, but we've got some awkward merged cells, which we don't like. So I'm going to transpose that just to, I know I don't need to, I could use a lookup that works both ways, but just for neatness sake. And then I'm going to let C be my conditions, and then I'm going to filter C where the last column of C, or any column really, is not 0, and that's going to tidy that. And then I'm going to regex extract from this range the first digits, our first number, times it by 1 so I actually have a real number. And then here I'm going to X lookup my 16 in this range, returning this range, and I want exact match or next smaller item because we don't want to go up to the next one. So 16 doesn't go up to 21, so it stays in the exemplary range. So we can then say our final answer is exemplary and joined with a space dash space with the integer value, and I didn't add my second ampersand. And then going to do this as a data table because we've got a very large spilling space, and it's based off the first example. And if I reference those, we get all good. Okay, level 6 is sort of similar but sort of different because this time we're not looking one mouth at a time, we're looking at one tooth. So if we were looking at this first tooth, the 30, we also need the 20. So we're going to do, firstly we need to turn this into a number. So I'm going to go back to level 3, grab my workings from there, put that in here. It's going to be pointing to the wrong cell, but when we point it at that, We don't get a number. Is that because what's gone wrong there? Hold on. Because I referenced the cell twice and I didn't move the second one. I think when I practiced this, I kind of created the cell as a reference. So now what I want to know is I want to know what rows is tooth 23. So if I look at the mouth, tooth 23, if I was just selecting this, is in the third row down and the seventh row across each time. So that's the information I need to work out. So what I'm going to do is I'm going to actually name, oh, didn't mean to do that. I'm going to name this as mouth. And so if I go into mouth, and then what I want to say is mouth equals this tooth, but because of the weird interaction between text and numbers, I need to turn this to text, and we then get a true here. So what I want to do is go by row and or, and then I'm going to wrap that in a X match on true to find the position of the row. And then if I copy that, if I fill that to the right, update the cell reference, and then change that to by col, we get the columns. So now what I want to do is do an index sequence of those. I'm going to create a sequence of 8 rows, starting at row 3, stepping up even by steps of 18, because we have 16 teeth down, 2 gaps, so that's 18. But we will see an error that's going to cause in a moment. That's fine, we'll fix it and it'll show us debugging. For sequences going to sides, so we've got 5 columns because there's 5 columns of teeth. We're starting at column 7, we're going in steps of 9 because there's 8 teeth wide plus a 1 row gap, so that's our offset there. And now if I index into the X-ray 1 using these row numbers and these column numbers, we're going to get nothing, but that's because I haven't included that top row, so I need to add 1 to my row numbers, and now I get those numbers. So we see on that first one we get 55, 35. These are the numbers coming through. So we now need the average of those and the integer values of that. And again, it's funny, I picked this up on this level 6 that we needed to round down, and I didn't go back to level 5 and correct it. So we do the same thing before with our lookup. So we need to find our conditions. So we're going to transpose, looking up the densities. I'll do the same little trick as before where I'm going to filter. So let C equal that, and then filter C where take the first column of C doesn't equal 0. And then we'll regex extract from here the first digit, times it by 1. And then our lookup is going to be X lookup 45 in this range, returning from this range, and this time we want, I think, next larger item because the order is reversed and I put too many commas there. So 45, we get down to 45, and we take the next larger. So yeah, sorry, that's intermediate. So our final answer is intermediate and space dash space and 45, and we will data table that. Let's go Alt DT. The column input is the original example, and we'll point to that, and we're all good. Okay, 30, just come to 14 minutes, and we've got level 7 in the bonuses. So I think we might be okay, but then this does get quite tough. So our patient is, we're just going to take the, do I need the number? Because I think my find from level 5 already takes that. Yes, actually, patient just equals that. My find, I'm going to copy this from level 5. I'll copy both of these. So I need the brushing score. So I've got the brushing score. My X-ray score is basically going to be the same, pointing at the correct cell and changing the named reference to X-ray 1. I've already put some conditional formatting in here just to kind of make it visually more obvious what's going on. And I'm actually going to change that to text just so it highlights more easily what's going on, and then that kind of ruins my conditional formatting, but never mind. Now we need to find the crooked teeth, and this was where there was a little bit of an issue in the live case, and I'll see if I can highlight why. So I'm going to make a copy of this because the find and replace, I'm looking for the cells with italics and red borders, but because of the coloring and everything else, that kind of messes things up. So what I'm going to do is I'm going to change the background to something plain, I'm actually going to delete all the text. I'm going to change the cell color so it's all the same anyway. So now when I select one of those cells, Control H, clear the formatting from my previous practice. So choose format from cell. I'm then going to select everything. I'm going to find all of those and replace them with an X. And what happens, we get 172 replacements, but weirdly down in row 102 and 108, which references patient 28, 2 of them didn't fill in. And I believe the markers basically took either answer from people, depending on which way they interpreted that or dealt with that, or if they even spotted it. So I'm going to leave it as it is. I think the answer file I've got now does the same thing, so we should be okay. But what I should have done first is I need to name this range and make sure it's the same size as the original. So it goes from B5 to AT148. So I'm going to go from B5, actually, let's go from AT148. Let's go from that cell up to B5, which is a bit easier to do it that way. And then let's name this X-ray 2. And you'll notice it calls it X-ray 1 already, but I've got experience that tells me when you copy ranges or copy sheets with ranges, the named ranges act funny, and I really need to work out why that is the case. But anyway, that's for another day. So I'm going to copy this over. But let's copy the formula so I don't have to re-reference the cell and just change that to X-ray 2. So we now see where the crooked teeth are for patient 1. And then I'm also going to grab the mouth map as well. And again, I'm going to wrap that in this. So I've now got basically all the information, and I need to be able to compare tooth by tooth what's going on. So what I'm going to do is I'm going to H stack. Oh, I need to put an equal sign, H stack, and then I'm going to call each of these ranges, because it's then going to put them side by side into a single array. But we're going to have lots of empty rows because of the nature of the data. So then what I'm going to do, similar trick to what I did with the conditions, I'm going to filter data where take any column from it. So data 1 does not equal blank. And that should, yeah. And then just for ease of ordering, let's sort this whole thing by the 4th column. So we've got the teeth names going up. So what we then need is our DRI score, DRS score, which is 0.35 times the brushing score plus 0.65 times 100 minus the density score, plus if the crooked equals X, then we add 15, otherwise we add 0. That gives us a score. I'm going to fill that down, and for some reason I get 3 extra rows at the end. And then what am I actually needing to find? So I want to find the tooth with the highest score. So I'm going to use my largest smallest lambda. Oh, largest. Let's try that again. Largest smallest. The range of values is these here, and I want to return the name of the actual tooth. And I just want that top row, so that's an optional argument, so just the top row. And what I want to do is I need to round those down, so I can do that to both. So integer value of both gives me 3368. I then need to text join those based on space dash space, ignoring empty cells, and we get 3368. So let's, which matches the example, DT based off patient 1. And if I reference those, yes, although patient 28 potentially was a different answer depending which case or answer file you're looking at. Right, we're on to the bonuses. How are we doing for time? 90 minutes. Okay, I think we're going to be okay. So in the mouth sheet, how many are there in total in the representation? We've kind of dealt with that a number of times, but we could say count all mouth should give us 32. Adding up all the digits individually, so what I could do is concat mouth. And then what I'm going to do is text characters that, and then times by 1, and then I'm going to sum that. And I get 224. How many teeth with an inclination of 2 over, i.e. how many crooked teeth were there? Well, when we did the find and replace, we saw 172. Again, if you because those two oddities, it could have been 174. And like I said, I believe the case administrators were accepting both. Based on the brushing cleanliness sheet, if we were to merge all 40 patients into a single one, adding the 40 values from tooth 11 and tooth 12, and what would be the name of the tooth? So the way I did this in the live case, which I'm sure there must be a better way of doing it, but I'm not sure. This is to do with brushing. So all I did was very, not particularly efficient at all. Was I basically said sum this plus this plus this plus this, and I did that. I'm doing the top left cell 40 times, which seems crazy, but it's one of those where the number's just about low enough that I'm sure I could do something with indexing, but by the time I did that and thought out how to do it, this ended up being just as well. It was accurate, I think, although prone to error, because once you get over a certain number of cell selections, you'll notice these cells don't appear in a different color, which means you can't be 100% certain that you have done it right. So if I drag that down, we start getting numbers, and if I drag it across 8 cells, we get different numbers, so they're adding up. And if I go to conditional format, highlight the top 10 items, and actually just highlight the top 1 item, we see the maximum is 2255, which is the fourth. It's the fourth one up, isn't it? Although, see, something's gone wrong here. I've got numbers where there shouldn't be numbers, so one of my cell references is slightly off. Let me just pause. Okay, I've had to think. In the interest of expediency, I know that is actually the right answer. So it's the third tooth up. I'm ignoring this one here. So the third tooth up in the mouth, which is 36, and 36 would be the lower left first molar. So if I go to the bonuses, lower left first molar, we get the correct answer. I think what I should have done or could do is basically leverage my level 6 work where this goes through every tooth, change it to look at the brushing score, and then basically data table every single tooth and see. I would have got the correct answer that way, but there's 2 possible solutions. I don't think you need me to show them. Because, I'm trying to keep this under half an hour. Last question. Of all the combinations between teeth and patients, filter and keep only those whose brushing values equal their density value of the results. What is the average of their density? So I think this actually isn't as difficult as I first thought it was going to be, and I might have had time to do this in the live case if I'd thought about it a bit more. So it's basically saying if we overlap these 2 different sheets, where are the teeth values where the number is the same? Because there's a few where that happens. So if we basically say, let's take the brushing map, and if we say equals the X-ray 1 map, we get a bunch of true and false. Now some of those will be patients, but some of those are also actual scores. But there's lots of those where that's kind of because they're equal to the number. So how am I going to do? I think I need to find some way to get the numbers only. Let me just have a think about this. Okay, so I've worked out how I did this when I tried it the first time, not during the live case. So to make this easier, let's 2-col the brushing range, and then let's 2-col the X-ray range. But what we see is there's lots of zeros. So if we just say 1 is equal, these are all going to come through, and we're actually looking for cases where actual numbers are the same. So just going to set some test conditions. So we're going to say we want to ignore anything where the length of this is or we want to get anything where the length of that is greater than 0, because those zeros will then, they won't disappear until I also again do that trick of putting this joining it with an empty text string to kind of get rid of all the zeros. So now we're just getting kind of actual values. So I'll do that the same for the second case, and then I also want to check where these 2 are equal. And I didn't use hash for that second one. And so now I only want to find those. And again, I might need to wrap those in. Let me just check that. Patient 1, that should be equal patient 2. Yes. So why is that when I do that on a spill array? Oh yeah, that's working. So I want all these where it's true on all of them. So I'm going to filter And it doesn't matter which of these I choose because we're only looking for the ones where they're equal. So we're going to filter those where these are true. So there's an actual value, and these are true, and these are true. Putting these inside brackets, not sure if I actually need to do that. And so now we get the ones where there's patients and one where there's numbers that match. So if I just then try multiplying that by 1, that'll get rid of all of the ones that aren't real numbers. And if I 2-col that using 3, I will get just the ones with actual numbers. And the question is asking me for the average of those rounded to the nearest digit, which would be 49.69 would give us 50. So if I go to the bonuses, round the answer to, we get 50, and that's correct. And how are we doing for time? 25.5 minutes, a couple of pauses in there just to double check my workings. So yeah, so in theory, definitely doable in under half an hour. I'm pretty sure no one did get it all in the time, but then it wasn't, obviously there were still other players who might have attempted it, might be able to do it in full time. So good case, great to practice this whole idea of, right, we've given a set of effectively mini maps of different things and indexing those. And I'm wondering whether there might be scope for a lambda where you have to think about how it works, where you say, right, here's my maps, here's the size of an individual map, and here's my kind of identifier that can then look into it. So the solution effectively I came up here, this ad hoc solution, but this way of doing it, yeah, there's a lot of work there. So I wonder if there's some way of kind of creating a lambda. So that'd be an interesting one to do. As I said, I'm really interested to see how other people manage this problem. Is there a better solution, a quicker solution than this kind of find the original starting point, create a kind of sequence of the cells you're looking for, and then kind of look those up. But yeah, interesting. What else? So like I said, in the live case, how did I actually do? So I did levels 1, 2, 3. I did level 4, but did level 5, but didn't round down. So got roughly half of these wrong. Did level 6, spotted the issue, should have realized that probably was the case in level 5, but didn't attempt level 7, got onto the bonuses, did bonus 1 and 2, attempted bonus 4 using the method that I showed you here, and actually doing it better than I did it here. Didn't have this random cell missing. But then basically I think I miscounted that this was the third one up. I think I thought it was the fourth one up, so I referred to the fourth tooth up. So did the hard work, got the easy bit missing. And then, like I said, the other thing I kind of slowed myself down on was I didn't fully understand or appreciate how this method, and like I said, I went and created a whole data where I listed out all the numbers, worked out whether they're up or lower, left or right, and combined these myself manually, which I didn't need to do. So that probably cost me a couple of minutes, which might have given me time for more of the bonuses. I don't think definitely wouldn't have given me enough time to do level 7. So yeah, great case. Hope, obviously I think it's the last one of the year, so I have to wait till next year for more for these. But yeah, good fun. Hope you enjoyed it. Like I said, if you've got any thoughts on those kind of looking up into mini maps within a larger map, let me know in the comments. All right, see you later.